Let's take a look at an example. Suppose we know a population doubles in size every 30 years. I'd like to know what is the continuous growth rate. Well, in order to do this, since it was mentioned that this is a continuous problem, I'm going to use my formula that would say that the population would equal the initial population multiplied by e to the kt. Now, I don't know what the population is, and what I'm going to do is I'm going to let p be the initial population. The neat part is if you don't like p, you could actually pick your favorite number. I'm going to work in the general sense, which is what your textbook does. So p is the initial population. If I want to know when it doubles, then the double would be 2p. If you don't like that particular setup and you want to use numbers, pick your favorite number as the initial population and then double it for the double population. So if I use my setup, the formula I would get is that 2p, which is that doubling population, is equal to the initial population, p, e to the rt. Well, notice it's r that I'm looking for because it's asking me what's the growth rate. And I know I have 30 years for my t, so I put the 30 in. So again, 2p equals p e to the r times 30. Again, if I had used my own population, it would have been twice that population equals the initial population, e to the r times 30. The neat part is now that I have p's on both sides, I can divide them out. So I end up getting 2 equals e to the 30r. And now I would need to solve this. And if I solved this, probably the easiest way is, for those of you who remember your logs, is to take the natural log of both sides. And we end up with natural log of 2 is equal to 30r. And we would solve for the r. Or right now, you can go in and use your calculator and use the intersect function. Your y1 would be 2, and your y2 would be e to the 30r. Make sure your 30r is all in parentheses, or 30x. When we solve this, we get r is 0.0231, or 2.31%. So our continuous growth rate would be 2.31%. If we were to actually write the formula, back from the general, we would actually have y equals p e to the 0.0231 times t, and we could find out what part of the population we had at any given time.